Venus, often called Earth's twin planet, is the second closest planet to the Sun and one of our nearest neighbors. Although it shares many similarities with Earth in terms of size, mass, and composition, Venus is an extremely hostile world, being the hottest planet in the solar system, with surface temperatures reaching around 900 degrees Fahrenheit, surpassing even Mercury, which is closer to the Sun. About 4.6 billion years ago, the solar system began forming from a cloud of gas and dust. Venus and Earth, being formed in nearby regions, developed similar compositions. Both planets have an iron core, a mantle of magnesium silicate, and a silicate crust. This proximity in formation led them to have almost the same size, with Venus being just 5% smaller than Earth and slightly less dense. However, despite these similarities, Venus underwent a completely different evolution. The Venusian atmosphere is made up of 96% carbon dioxide, resulting in a runaway greenhouse effect that traps heat. This makes Venus the hottest planet in the solar system, with temperatures high enough to melt lead. In comparison, Earth's atmosphere contains only about 0.04% carbon dioxide, which allows for moderate, life-supporting temperatures. One critical factor that led Venus down this path was the absence of active tectonic plates. On Earth, tectonic plates play a crucial role in the carbon cycle, helping to regulate carbon dioxide levels in the atmosphere. These plates recycle carbon, allowing carbon dioxide to be released into the atmosphere and eventually reabsorbed by the planet. On Venus, this recycling never occurred. Without tectonic plates, carbon dioxide released by volcanic eruptions accumulated in the atmosphere, intensifying the greenhouse effect and further raising temperatures. Additionally, Venus's rotation is drastically different from Earth's. Venus rotates in a retrograde motion, meaning it spins in the opposite direction of most planets, including Earth. This probably occurred due to a massive collision during the early formation stages, which inverted its rotational axis. As a result, a day on Venus is longer than its year, taking 243 Earth days to complete one rotation. Its axial tilt is also only about 3 degrees, compared to Earth's 23.5 degrees, preventing the formation of seasons and maintaining a highly homogeneous climate. During the first billion years of the solar system, both Venus and Earth were bombarded by numerous asteroids and comets. On Earth, one of these collisions resulted in the formation of the Moon, which helped stabilize Earth's axial tilt and played an important role in climate development. Venus, however, wasn't as lucky, and its retrograde rotation may have contributed to its unstable environment. The dense and toxic atmosphere of Venus is composed not only of CO2, but also thick clouds of sulfuric acid, which make direct observation of the surface impossible. The atmospheric pressure on Venus's surface is about 90 times greater than on Earth, similar to the pressure found almost a mile underwater on Earth. This dense atmosphere also creates a corrosive and highly inhospitable environment for any form of life. Though Venus is now an extremely hot planet, there is evidence that, in the distant past, it may have had liquid water on its surface. Observations of water vapor and deuterium, a heavier isotope of hydrogen, in its atmosphere indicate that during its youth, Venus may have maintained oceans for billions of years. Deuterium is particularly interesting because its presence suggests that large amounts of water were lost to space over time, the result of evaporation caused by rising temperatures. Models and simulations suggest that Venus could have been habitable in the past. In a study published in, scientists propose that the planet may have even had tectonic plates billions of years ago, which would have helped regulate its atmosphere. This raises the question of whether Venus was once similar to Earth in terms of habitability, before it transformed into the inhospitable planet we know today. The discovery that Venus may have been more habitable in the past suggests that planetary habitability could be a temporary and fragile state. Comparing the evolutionary history of Venus and Earth offers important lessons about the fragility of habitable environments. Venus's fate serves as a reminder of how geological and atmospheric factors can radically transform the nature of a planet. The absence of tectonic plates and the uncontrolled greenhouse effect on Venus contributed to its transformation into an inhospitable world, while Earth so far has maintained an atmosphere and temperatures suitable for life. Future space missions, such as those planned by NASA and the European Space Agency, ESA, aim to study Venus in more detail. These missions will seek to better understand the geological and atmospheric processes that shape the planet and determine whether Venus had a more habitable past. With these missions, we hope to learn not only about Venus's past, but also about how planetary environments can evolve over time. This knowledge could be crucial to the preservation of our own planet. Now it's your turn. What else would you like to know about Venus? Share your thoughts and theories in the comments below, and let's explore the mysteries of the universe together.